Hello and welcome. In this tutorial video, I will talk about the functionality provided by the KIWI Explore module to automatically handle observation records that would be below the lower limit of quantification. KIWI Explore provides 5 different methods for handling BLQ data. These methods require the presence of variables in the dataset to automatically process the information. In this video, I will describe those 5 different methods, talk about the variable requirements, and show the effect of these 5 different methods on the EDA displays. Let's now switch to the application. I have opened KIWI Explore for a single dataset, and this page is shown side by side with the Profile Manager, which I will use to illustrate the different settings that you need to define to implement the different method of handling BLQ. The default behavior of all the EDA categories is to simply ignore the issue of BLQ data and to simply use the information that is provided in the dataset. So I will illustrate that default behavior with a scatter plot profile. This is a spaghetti plot design showing the concentration or some observation versus time since first dose. Each line represents the profile collected in a single subject, and this is the data collected in study 1 for a dose of 10. The red horizontal line represents a theoretical BLQ value of 20. We're assuming here that the analytical lab allow the release of measurements below the BLQ, which is a pretty rare thing. But we're going to use this data to illustrate how you can process this information below the red line using one of the other 4 different methods of handling BLQ data. So if I go to the definition of this default setting, this no exclusion of BLQ record, and if I go to the BLQ handling panel, this panel contains 4 different rows which will define how to handle the BLQ overall, or the BLQ records overall. The first row is defining the handling method. The other rows define different parameters that or values that are required for some of the methods. So the first field is set to do nothing, which is again the default for all the EDA categories, and essentially that would mean there is nothing that is performed on the dataset relative to BLQ data. So the first real way or method to act upon BLQ information is to exclude that information. This is shown in this profile. All the information below the red line was excluded, and you only see the information that is above. So one of the consequences was the change in the range of the time since first dose. You can implement this method by going to the BLQ handling panel and set the handling method to the exclude choice. You will need to provide a BLQ variable. This would be a variable present in your dataset, and that variable would identify which records are below the lower limit of quantification and which one are above, based upon your observation or your dependent variable. assuming that the BLQ variable identifier, or the BLQ identifier variable was BLQFN. Records that are associated with BLQFN equals 0 will be considered to be above the LLOQ. So those records would not be considered BLQ data. Any other values, whether it's a negative or a positive value for the BLQFN, would be associated with records considered to be BLQ. So typically you would have a variable that is 0 or 1. 0 would be data above the LLOQ, 1 would be the data below the LLOQ. And for the exclude method, the all that data with BLQFN equal 1 would be excluded. So that first method is an exclusion method. The other three methods are not excluding data, but are transforming the data. And you have three different options. Either you set the value of your dependent variable to 0. So whatever information was in your dependent variable will be transformed into the 0 value. That's the first option. You can transform your dependent variable value into half the LLOQ value, or set your DV variable or dependent variable to the actual value of the LLOQ. So just to show you the impact, this would be the original data, setting all the data, the BLQ data to 0 would transform the data as such. And the way you do that is again going to the BLQ handling panel. You set the first, the handling method field to set to 0. Again, you need a variable indicating the or identifying your BLQ records. I kept the BLQFN variables selection here, and that's all you need for this third method. The fourth and the fifth method require some additional information. So I'm going to show the fourth method, setting the BLQ, the dependent variable, to half of the LLOQ value. So in this case, 10. So you get this flat line at 10. So when you set the handling method field to set to half LLOQ, you need to provide a variable identifying the BLQ record, and you need to provide information about what is the LLOQ. There are two ways to do that. You can either set a value that would be applied to all the data set. So all the records would be assumed to have been obtained with an assay that had an LLOQ of 20, and 0.5 times 20 would be 10, and that's what was represented here. The alternative option is to use a variable storing the information of the LLOQ for the assay that was used for each record. This is what I've done for this last profile. I've used a variable to define the LLOQ information. So I set my handling method field to set to LLOQ. I kept my BLQ variable to BLQFN, and I set or selected a variable, in this case LLOQ variable, for the LLOQ field. the LLQ variable in my data set had different values for different subjects. That was purely hypothetical. As for some subject, the value was set to 10, and for some it was set to 15. So that is probably a little bit unrealistic for a phase 1 study, which is what this data was represented. But if you were to represent or use the data collected on different studies, it is not it is often the case that the data collected in different study was obtained with different assays with different characteristics. So that's one way to handle this situation, is to use an LLQ variable. So in summary, you have 5 different methods. One consisting of doing nothing, one that will exclude the BLQ record, and 3 methods that would transform the data either to 0 or have the LLQ or the LLQ information. Depending on your plot or the type of EDA that you want to create, you may want to use one or the other. Sometimes it's interesting to include the BLQ information if you try to get some form of distribution of your sampling time point in a histogram or a bar chart. In some scatter plot or a line plot, it is maybe better to exclude the BLQ. There is one situation which I want to highlight now. It's an exception to the behavior that I've described so far. One type of summary statistics table is listing the value of your dependent variable for each subject based upon typically a time variable, and then it displays the statistics at the bottom of the table. So this design, I'll just go back to my view side by side. This design is the individual value in rows statistics in column, and this is a design that is quite typical of a non-compartmental analysis table, which summarized both the individual value of the concentration and some form of summary statistics on them. There are rules to report the result of this NCA analysis in terms of what you need to report in the tables and how to calculate the statistics. So we have implemented those rules when BLQ data is present in the data set, and how they're reported in the tables and used in the statistics. There are 2 different situations, one where you exclude the data and one where you're transforming the data. So I will illustrate both situations, and by transformation of the data I mean transformation to 0, have the LLQ or the LLQ. So the first situation is when you exclude the data, and this is done exactly the same way in the BLQ handling method. Is you just want to exclude, or you want to set the handling method to exclude, and you need to provide a variable that identify which records are BLQ and which one are not. We'll talk about this last field a little bit later. So I want you to look at this table, and you can see that the LLQ information is actually reported as this lower than LLQ. What that means is that the data is not, strictly speaking, the data is not excluded before it is shown in the table. It is just reported differently in the upper section of the table. The data is only excluded when the statistics are computed. So if you look at, if you compare this column to this column had no LLOQ information and no missing information. Therefore, the number of record was 6. In this column, there was some information that was LLOQ that we decided to exclude. Now the number of record for the computation of those statistics was 5. So the 6 rows minus the LLOQ. The table also report the missing value, which is the sum of the records that were actually missing, so not measured, and the one that were LLOQ or considered as LLOQ. So in this column you can see a mix of LLOQ and missing information, and the missing row indicate the value of 3. So that's for the exclusion of the BLQ record. I have another similar table where the data was, I believe, set to the LLOQ, or maybe half the LLOQ. No, it was set to 0. And in that case, the when LLOQ is present in a column, it is not excluded. So you can see that I've used 6 values to, or KIWI has used 6 values to compute this mean and SD minimum and maximum statistics. But the value that was used for this record was not the original DV value, but 0. So if I compare the value for this first method that did not exclude the data, I have a value of 32.8 roughly for the mean, and in this profile I have a value of 29.5. So you see the difference in statistics. Coming back to this panel of settings for summary statistics table, the panel includes another setting, which is the threshold of BLQ record allowed to display statistics or to compute statistics in a table. The default is 50%. And so here I'm trying to find, no, I don't think I have. At some point all my data was missing. Or LLOQ, so it's not necessarily super meaningful. What I meant was if, well, actually maybe in this one that would be, yes, that is actually the case here. I had 3 records that were BLOQ, and I had 3 methods, 3 records BLOQ and 3 records that were above the LLOQ. That was exactly on 50%. In that case, where the table do not report any statistics, you will see NAs instead of a mean of the 3 remaining values. So that again is a rule, I believe, of the typical NCA reporting methods. If you want to use a slightly lower threshold, like 20% or 30%, you can change that here, and that would affect how these stats are either shown or just not reported. A last point that I want to make about the exclusion of BLQ records. So typically, you will use this method of handling the BLQ when your EDA report information about the dependent variable, so your DV variable or your concentration variable. That being said, if you have, let's say, a box plot showing the distribution of age versus, I don't know, gender, if you're using an exclusion methods for, or an exclusion option for the handling method, you will end up excluding records which also contain information about age and gender. So you can also influence the subset of data shown in other plots that do not necessarily involve the dependent variable, concentration, or whatever biomarker will be measured. So you need to be careful about that, not necessarily to use a handling method or an exclusion method when when you don't use the observation or concentration variables in your EDA. With that, that concludes our presentation of the handling methods for BLQ data in the KIWI Explore module. Thank you.